Woo. So here we are at the park entrance. Just walked out here. Here's the park. Here's some more of that granite and gneiss exposed. And once again, we see these streaks. Now these scratches caused by glaciers, and they're pretty big and pretty long. Here's some better ones over here. And they're cool because they tell us the direction of the glaciers. Now, I'm going to walk out of the park. These outcrops here. This is the continental crust poking up to say hello. Hello, continental crust. So, we're walking just outside of the park. And because it gets a little loud on the highway, I'm going to start narrating what we're going to see out here. So, we're going to take a look and we're going to see three major types of rock. We're going to see basalt, which is an igneous rock. We're going to see granite, which is an igneous rock. And we're going to see sandstone, which is a sedimentary rock. Now, what's special about this spot out here that we're walking towards is kind of famous to geologists. There's actually a picture of this particular outcrop in my historical geology textbook. Why? Why do they care about an outcrop just outside of Bay? It's because here we see evidence of the great unconformity. Unconformity is spelled UNCONFORMITY. So this is a great unconformity. And what an unconformity is a layer of missing rock. So we're going to go ahead and we're going to take a look at this layer of missing rock. And the amount of rock missing is about 500 million years worth. Now, we have three major agents of weathering and erosion. Those are wind, water, and ice. Now, of those three, hang on, truck. It's going to be loud. Now, of those three, which one is the really powerful one that's going to completely destroy the bedrock? Wind, water, or ice? I'll give you a moment to think about it. Very good, it's ice! So, I'm really doing the Dora the Explorer thing. So, we actually, in this part of the park, and a few feet from each other, can see evidence of two different glaciations separated by almost 1 billion years. So first, we see this granite right here. More recent than that is the basalt. Now, basalt has a lot of iron in it, so you're going to see iron oxidation, which is this orange stuff. This is what kind of weathering? Excellent. It is chemical weathering that you're seeing right here. So we see evidence of chemical weathering on this basalt. Now, this basalt formed later than the granite rock did. Now, we actually see right here, before this retaining wall was built, this was a nice, neat little glacial trough. This was carved by the Pleistocene glaciers probably about 21,000 years ago. Here we have another band of gneiss. Now, it's cut into gneiss that's probably much older. It's probably about 1 billion years old. In that neighborhood. So we're taking a walk over here. I know it's pretty noisy and the camera's pretty jiggly. I'm not Federico Fellini. You'll have to forgive me. Does anyone know who Federico Fellini is? Email me who Federico Fellini is and I'll give you 2 points extra credit. I have all sorts of obscure jokes. All right, now we're starting to see evidence. See those pieces of rock that are broken and fallen down? Those big platy rocks. This this stuff right here, this orangey stuff on my camera. This right here is that sandstone. So we're getting closer and closer. And here we have it. The Great Unconformity. So this sandstone here formed on a Cambrian beach about 500 million years ago. You can see right here. It's orange because there's a lot of iron oxidation. Once again, evidence of chemical weathering. What we're looking at right here is the rock that isn't there. So in between this granite and this sandstone, there's a thin line where we should see about 500 million years of deposition, and we don't. Why is that? This is from a much older glaciation than the Pleistocene glaciations. So right over there at the front of the park, we have evidence of glaciers 21,000 years ago. This is evidence of snowball Earth, when the entire Earth froze over with water. And that it occurred about somewhere in the neighborhood from about 1 billion years ago to about 800 million years ago. We had snowball Earth. So it's when the entire Earth was completely frozen over with glaciers. So take a look here. So that missing rock, that Great Unconformity, is a sign that we had this huge glaciation occur. Now, let's head over to the last spot.